Hi guys, today we're talking about trigonometric ratios, Unit 3, Day 11. Our objective is that I will be able to use trig ratios to determine the side length of right triangles. So there's some right triangle vocabulary that we just need to go over real quick. First, we have this strange symbol right here that looks like a 0 with a line that goes through it. And we call that Greek letter theta. And theta oftentimes represents the angle that we're looking at. So in this case, if we're looking at that angle right here, theta represents the angle measure of that specific angle. Hypotenuse is the same as how we've talked about it before. It is always opposite our right angle. It is also your longest side. Now, opposite and adjacent are talking about their position in relation to where theta is. So if we know theta is our angle right here, then opposite of theta is the side that we name opposite. Adjacent from theta, or next to, is talking about the side that is next to theta, but not the hypotenuse. So our first teacher example is to label theta, hypotenuse, opposite, and adjacent for our triangle below. So theta is our only angle, and here the angle that's indicated here is t, so we'll put that as theta. Once we have our right angle here, opposite our right angle, we know that 65 is our hypotenuse. From theta on the other side, that's our opposite, and then next to theta is our adjacent. So label those 4 things for your student example number 1. Now, once we have those terms defined, there are 3 trigonometric ratios that we're going to be working with primarily: sine, cosine, and tangent. So sine, cosine, and tangent. Now these are 3 ratios or fractions that we use with right triangles. For example, if we're talking about sine of an angle theta, we represent that ratio as opposite over the hypotenuse. So it is a ratio of the sides of our opposite side and our hypotenuse. Now, if you're doing cosine of an angle measure, that is a ratio of our adjacent side and our hypotenuse. And then lastly, tangent is a ratio of our opposite over our adjacent. And these ratios are useful because they can help us determine the side lengths of triangles. The phrase SOHCAHTOA gets thrown around a lot as a mnemonic device to help us remember these ratios. So sine is that first S, O is for opposite, H is for hypotenuse, right? So is there, cosine, adjacent, hypotenuse, and then tangent, opposite, adjacent. All right. These are really useful things to have memorized. They come up again in most of your math classes going forward. What's really, really cool about these ratios is that a triangle could be larger or smaller with that angle measure, but if that angle measure stays the same, the ratio, so the opposite over the adjacent or the opposite over the hypotenuse, stays the same. And that's why, with that known ratio in mind, we're able to solve for different values. Let's try a teacher example right here. It says determine the value of x. So if we know this right here is a right angle, and you know that this is 30 degrees. and we're looking for x over here, we can use a trig function to help us solve for it. So what we're going to do is label all of our sides first. So 30 is our theta, 15 is the hypotenuse, x is our opposite, and up here is adjacent. Now, since we're given information about the hypotenuse and we are looking for the opposite, we would want to use a ratio that includes hypotenuse and opposite, which in this case is sine. So sine of theta equals opposite over hypotenuse. And what we have to do there is plug in our given values. Well, we know theta is 30, so we do sine of 30. What is our opposite? Is x, and our hypotenuse is 15. In order to solve an equation, we want to isolate x. So in this case, we're going to multiply by 15, and then we'll multiply by 15, and then x equals 15 sine theta. And when you get to that point, you actually can just put it straight into the calculator. 15 sine of 30 gives you 7.5. So it tells you that x equals 7.5. What I hope you recognize, though, is that trig ratios are not the only way to solve this problem, because we have seen 30, 60, 90 triangles before when we do special right triangles. So right here, if we know this is 30 degrees, then we can label using our 30, 60, 90 triangle rules. And in that case, we have this becomes, we'll call it a square root 3, and 2a. And I know that a equals x, 15 equals 2a, and your other side, we'll call it d for adjacent, equals a square root 3. 15 equals 2a. I'm dividing by 2 on both sides. A equals 15 over 2, which is equal to 7.5, which is what we got when we use our trig functions. Take a little bit of time and try student example number 2. Remember that when you're writing your summary, it should be 3 to 5 sentences. It should include the objective for today, as well as appropriate academic vocabulary. I'll see you guys in class. Bye.